Welcome to the SOM tutorial. I'm going to show you how to use the SOM tool. You navigate to the page where you can input a reactant pair. And then if you just want to get started, you can use an example. You'll see this is a very simple reactant pair. We'll also go through an example of how to add your own. You're going to be prompted for a bit of information. First, you need to name this experiment. This can be a notebook reference number, something simple to help you remember. And then you're going to need to input the reactants. Starting with the aryl halide, we're going to select the structure in your favorite editing software. Click Edit, Copy As, Smiles. The hotkey for this is Alt-Control-C in ChemDraw. We're going to paste that into the Smiles box. And we're going to verify that the structure drawn by SOM looks like the structure that we were intending. We're going to do the same thing with the nucleophile. I'm using the hotkey here. Again, verify that it's the correct structure. You need to give a unique name to each reactant. This is important, especially if you're making predictions for multiple reactions. Now, if I'm done, I can analyze this using SOM, but I can also batch my predictions. So let's say I have another experiment that I want to run. I can add a new one. I'll scroll down to this pre-drawn experiment. Say I have a new notebook reference. Now I have a different coupling here, and I would expect that the catalyst, solvent, and base identified by SOM might be different. So I'm going to input the reactants. Now, if I make the mistake of putting the nucleophile into the aryl halide box, you'll see that I will get an error. That is a good thing to make sure that these don't get mixed up. I'm showing one example of an aryl chloride and one example of an aryl bromide. Those are the two types of halides that we have designed this tool to work on. Once I have named everything, I can add this to my prediction table. Now I can run this and click Analyze using SOM. However, in the interest of expediency, I've already done that with these exact requests. This is what the output will look like. Right off the bat, you can export your results. There are a few options here. You can look at a specific reactant pair or all of the job. But let's say we want to browse through these predictions. Start with our test case. This is simple. Predicted to give a reasonably high yield with these conditions. Then go to view results. I will see the reactants redrawn. And I will also see the top conditions shown at the top of the page. And I will show a density plot that can be interpreted much like a histogram. You can quickly identify how many conditions were predicted to work. And then I can see a breakdown based on the solvent-base combination and the catalyst. And lighter colors like yellow indicate a higher yield. Purple indicates a lower prediction. I also have this data in tabular format on the right. I can interact with this density plot and grab this cursor and drag it to set a cutoff. Let's say I'm only interested in the top third or so of this yield range. I will see that there are certain catalysts that are predicted to work in quite a few different conditions. Those will be recapitulated on the right. If I hover over these, it will show me their structures. I can export these visualizations or in tabular format, the predictions, and I can do anything I want with those. If I go back to the results and look at one of the couplings that we actually put in ourselves, here's the bromide with this alkylamine. Now, right off the bat, again, the reactants are redrawn. The top conditions are different from before, as we expected. And then if you look at the yield density plot, you can see that these predicted values definitely tend towards the lower end. Isn't really surprising. Now I can set a cutoff here, and if I'm pretty aggressive, I'll see that there are, a handful of conditions suggested. I can take my pick. Then I can export these results the same way I could before. If I go back and I look at the results for the aryl chloride, again, these are different, very different looking reactants. If I go to the view results, you'll see quite a few more conditions are predicted to work. There's a lot less steric hindrance on the electrophile, nucleophile than aniline, not an alkylamine. A lot of reasons why we might expect this. If I set a filter for the predicted yields, and let's say I want to look at the high end of this density plot, you'll notice something, that is the base solvent combination is kind of more important than the catalyst. That is, the strong base seems to work much better. That's a prediction, at least. And then the catalysts, there are quite a few that seem to work quite well. Now you can see on the low end, we've got about 60% up to just over 80%, and I can export these results. That's how to use the SOM tool to input structures and get predictions. Now, if you want to learn a little more about it, you can do that. You can click on About SOM. It'll take you to a tab that looks like this. If you have any feedback, please feel free to give us some feedback. You can read about what this tool is and how it was developed. You can look at the training data yourself. You can inspect, which reactions gave reasonable yields. You can look at the specific combinations and their yields. You can also go to GitHub and get access to the code that was used to make this tool and do something on your own with it. You can go see the publications. We have a science paper and a ChemArchive manuscript.